December 31st, 1944, Ardennes Forest, Belgium. Oberst Wilhelm Mohnke crouched in the frozen foxhole as American artillery began its evening harassment fire. His veteran grenadiers had survived 3 years on the Eastern Front, where they'd learned to recognize the distinctive whistle of incoming shells and time their cover accordingly. Artillery was predictable. You heard the whistle, you went to ground, the shell landed, you counted to 3, you emerged and continued fighting. This was the arithmetic of survival that had kept them alive through Russia. The first shell exploded 50 feet above their position. Mohnke felt the hot metal fragments tear through the air where standing soldiers had been a second before. 3 men died instantly, shredded by shrapnel that came not from the ground, but from directly overhead. Before anyone could process what had happened, a second shell detonated in mid-air, then a third, then a dozen more. The artillery barrage wasn't hitting the ground at all. Every single shell was exploding precisely at the optimal height to maximize casualties, creating a steel umbrella of death that no foxhole could protect against. In 7 minutes, Mohnke's company of 120 men suffered 48 casualties, not from shells hitting nearby positions, not from lucky direct hits, but from scientifically perfect airbursts that his veteran soldiers had no defense against. The Americans had found a way to make every artillery shell explode at exactly the right moment. No more guessing. No more luck. Just mathematics and physics turned into a weapon that made traditional cover meaningless. What Mohnke couldn't know was that the Americans had deployed a technology so revolutionary that it would fundamentally change warfare forever. A miniaturized radar transmitter, small enough to fit inside an artillery shell, sophisticated enough to detect the ground rushing up beneath it, and fast enough to trigger detonation at the optimal killing height. The VT fuse, officially the variable time fuse, but known to its creators as the proximity fuse, represented a quantum leap in weapons technology that Germany's best scientists couldn't match. Within weeks, German intelligence would capture duds and discover vacuum tubes inside artillery shells, electronics that could survive being fired from a cannon at forces exceeding 20,000 times gravity. They would realize with dawning horror that American industrial capacity had miniaturized radar technology, then mass-produced these miracles by the millions, then loaded them into artillery shells to be expended by the thousands every single day. The proximity fuse would kill more Germans than any other single American weapon system, and the Wehrmacht would never develop an effective counter. The story began in 1940, as German aircraft pounded Britain. British anti-aircraft guns were firing tens of thousands of shells daily with a hit rate of 1 aircraft destroyed per 20,000 rounds expended. The mathematics were brutal. Each bomber shot down cost more in ammunition than the bomber itself was worth. Anti-aircraft fire was effectively useless. The problem was timing. An anti-aircraft shell traveling at 2,000 feet per second had to explode within 70 feet of a target moving at 300 miles per hour to guarantee destruction. A traditional time fuse required gunners to estimate altitude, calculate the shell's flight time, set a mechanical timer, load and fire. By the time the shell reached altitude, the target had moved. Near misses were common, direct hits were miracles. Merle Tuve, director of the Department of Terrestrial Magnetism at the Carnegie Institution in Washington, assembled a team in September 1940 to revolutionize warfare. Their mission seemed impossible. Create a miniature radar unit that could fit inside an artillery shell, survive the shock of being fired, operate reliably despite spinning at 300 revolutions per second, function in temperatures ranging from -60 to +160 degrees Fahrenheit, cost less than $50 to manufacture, and work the first time, every time. The technical challenges defied everything electronics engineering knew in 1940. Vacuum tubes were fragile glass devices that shattered if dropped. The VT fuse would need to survive acceleration forces of 20,000 Gs, equivalent to having an anvil the size of a house land on the tube during firing. Radio components required hand wiring and careful adjustment. The fuse would need to be mass-produced by the millions using automated assembly. Electronic circuits consumed significant power. The fuse had to operate on a battery smaller than a thumb. Section T, as Tuve's proximity fuse development team was designated, solved each impossible problem through innovation that pushed the boundaries of physics and engineering. They developed vacuum tubes with specially designed filaments that could withstand cannon acceleration. They created radio circuits that self-tuned through the effects of shell spin. They invented batteries using materials that could store more power in less space than anything previously manufactured. By August 1942, they had a working prototype. The test that changed warfare occurred on August 12, 1942, off the coast of Delaware. The USS Cleveland, a light cruiser, fired VT-fused shells at radio-controlled target drones. The first drone was destroyed on the third shot, the second on the second shot, the third on the first shot. Navy observers who had expected a success rate of perhaps 10% watched in astonishment as the new fuses achieved better than 50%. Admiral Harold Stark, Chief of Naval Operations, immediately ordered crash production. What followed was a manufacturing miracle that epitomized American industrial capacity. By October 1942, production began at three main contractors: Crosley Corporation in Cincinnati, Sylvania Electric Products in Massachusetts, and Eastman Kodak in Rochester. By June 1944, production reached 1 million fuses monthly. By war's end, American factories had produced over 22 million VT fuses, each containing sophisticated electronics that German industry couldn't replicate in any quantity. The security surrounding the VT fuse was unprecedented. President Roosevelt personally ordered that the weapon could only be used over water initially, preventing capture of intact examples. Every fuse contained a destruct mechanism that would shatter critical components if the shell failed to detonate. Soldiers were forbidden from discussing the technology. Intelligence services fed German spies false information suggesting the fuses operated on photoelectric principles rather than radar. German Kriegsmarine ships encountered VT-fused anti-aircraft fire first. In January 1943, German bombers attacking Allied shipping in the Mediterranean found themselves flying into walls of perfectly timed airbursts. Pilots, who had learned to evade traditional anti-aircraft fire by varying altitude, discovered that the new American shells seemed to follow them, exploding regardless of their maneuvers. The casualty rate among Luftwaffe anti-shipping units tripled within weeks. Interrogated Luftwaffe pilots told intelligence officers impossible stories. American shells that exploded when they came near aircraft. Anti-aircraft fire that hit on the first salvo. Flak patterns that created impenetrable barriers. German intelligence initially dismissed these reports as combat stress. The technology described was simply beyond German capability. The Battle of the Philippine Sea in June 1944 demonstrated the VT fuse's devastating effectiveness. Japanese aircraft attacking American carriers encountered anti-aircraft fire with unprecedented lethality. Of 373 Japanese aircraft that attacked, 243 were destroyed by ship-based anti-aircraft fire, primarily using VT-fused shells. The Americans called it the Great Marianas Turkey Shoot, but the VT fuse's greatest impact would come on land. In December 1944, with German forces no longer able to capture intact fuses over Allied-controlled territory, General Dwight Eisenhower authorized use of proximity-fused artillery shells during the Battle of the Bulge. German forces advancing through the Ardennes were about to encounter a weapon that would redefine ground combat. The initial German advances during the Bulge relied on traditional combined arms tactics, refined through 5 years of warfare. Infantry moved through forests where American artillery struggled to achieve effective tree bursts with conventional contact fuses. German commanders had calculated that American artillery would be less effective in the Ardennes' rough terrain. They were catastrophically wrong. On December 22, 1944, American artillery battalions supporting the 101st Airborne Division at Bastogne received their first shipments of VT-fused shells. Fire direction officers barely believed the briefings. Set the fuse for VT mode. Fire normally. Every shell will airburst at optimal height automatically. No corrections needed for terrain, no bracketing shots required, just point and fire. The 321st Glider Field Artillery Battalion conducted the first fire mission with proximity fuses against German forces, massing for an assault on Bastogne's perimeter. 12 guns, firing for effect without ranging shots, delivered 60 shells that all detonated in perfect airbursts over the assault formation. German officers watching through binoculars saw their assault companies shredded before they could advance 100 meters. Casualties exceeded 30% in less than 2 minutes. The attack collapsed before it began. German medical officers examining casualties found wound patterns they'd never seen before. Traditional artillery created localized clusters of casualties. VT-fused artillery created uniform casualty patterns where everyone in the beaten zone was hit. The fragments came from directly overhead, penetrating helmets, striking spines, hitting areas that foxholes and trenches were designed to protect. Even veteran troops who had survived years of combat were helpless against this scientific destruction. Oberst Otto Skorzeny, commanding the 151st Panzer Brigade during Operation Greif, reported to Army Group B headquarters on December 26th. The Americans possess artillery fuses of a new type. Every shell bursts at the optimum height regardless of terrain. Our casualties from artillery fire have increased by a factor of 4. Troops are demoralized. They believe the Americans can see them individually and target them specifically. This is destroying unit cohesion more effectively than the casualties themselves. The psychological impact of proximity-fused artillery exceeded the physical damage. German soldiers learned that traditional cover was ineffective. Foxholes that would protect against conventional artillery offered no protection against fragments coming from directly overhead. Trenches became death traps. Soldiers began to refuse advancement orders, not from cowardice, but from rational calculation that movement under VT-fused fire was suicide. German artillery officers who examined captured proximity fuses were stunned by what they found. Inside the relatively small fuse were components that represented electronics miniaturization beyond anything German industry could produce. 5 vacuum tubes smaller than a finger, a transmitter operating at frequencies requiring precision German radar systems occupied entire rooms to achieve. A battery chemistry unknown to German researchers, circuit designs that self-compensated for temperature, spin and altitude variations, all assembled with precision that suggested automated manufacturing on an enormous scale. Dr. Wilhelm Ruppel, director of German radio intelligence, submitted a report in January 1945 analyzing captured proximity fuses. His conclusions were stark. The American VT fuse represents a convergence of at least 6 distinct technological advances, any one of which would be considered a significant achievement. Most significantly, the scale of deployment indicates the Americans have solved these problems not in laboratory conditions, but in mass production. Intelligence estimates suggest production of at least 1 million units monthly. This production rate exceeds our total production of all radio components for all purposes. The Americans are expending in artillery shells more sophisticated electronics than we possess in our entire radar defense network. The impact on German military operations was immediate and cascading. Artillery that had been a supporting arm became a decisive weapon. American infantry units that previously required multiple fire missions to suppress German positions now achieved suppression with single volleys. German counterattacks that relied on speed to minimize exposure to artillery fire found that speed was irrelevant when every shell achieved perfect airburst. By January 1945, German tactical doctrine was being rewritten in desperate attempts to counter the proximity fuse. Orders went out to disperse forces more widely, increasing the distance between individual soldiers. But wider dispersal reduced unit cohesion and made coordination impossible. Commanders were ordered to move only at night, but American artillery fired VT-fused illumination rounds that turned night into day. Troops were instructed to advance in short rushes, but VT-fused artillery could bracket an area faster than soldiers could move through it. The Battle of Remagen demonstrated proximity-fused artillery's strategic impact when the Ludendorff Bridge was captured intact on March 7, 1945. American forces established a bridgehead on the Rhine's east bank. German forces attempted immediate counterattacks to collapse the bridgehead. American artillery battalions, now supplied primarily with VT-fused ammunition, created a protective umbrella over the crossing that German infantry couldn't penetrate. In 3 days, American artillery fired more than 10,000 VT-fused shells, creating a beaten zone where German casualties reached 70% in some units. General der Infanterie Otto Hitzfeld, commanding 67th Corps opposing the Remagen bridgehead, reported to Field Marshal Albert Kesselring, "American artillery fire has reached a level of effectiveness that makes offensive operations suicidal. Their air-bursting shells create killing zones where survival is random chance. My divisions are at 20% strength, not from continuous combat, but from 3 days under this fire. Unless we develop counter-technology immediately, conventional military operations are impossible." But counter-technology wasn't forthcoming. German research into proximity fuses had begun in 1942, but remained at laboratory stage through war's end. The miniaturization challenges that Americans had solved through brute force application of industrial resources and scientific talent simply exceeded German capacity in 1945. Germany was fighting for survival with disrupted supply chains, bombed factories, and scientific resources devoted to desperate wonder weapons. Major Franz Kurowski, operations officer for the 18th Panzergrenadier Division, kept a detailed journal captured by American forces in April 1945. His January 30th entry described proximity-fused artillery. "Today, we experience the American Wunderwaffe, not rockets or jets or atomic devices, but simple artillery shells that somehow know when to explode. An artillery barrage that previously would have suppressed our positions now destroys them. Casualties are 4 times normal rates. Soldiers refuse to leave bunkers even when ordered because they know that any movement above ground under this fire is death." The proximity fuse's effectiveness extended beyond anti-personnel use. VT-fused shells proved devastatingly effective against aircraft. American anti-aircraft battalions achieved hit rates against German aircraft that exceeded 50%, up from the pre-VT rate of 0.005%. German pilots who had learned to evade traditional anti-aircraft fire found themselves flying through mathematically perfect kill zones where evasion was impossible. German jet aircraft, the Me-262 and the Arado R-234, represented technological advantages that conventional anti-aircraft fire couldn't counter. But VT-fused anti-aircraft fire didn't require precise targeting. The proximity fuse would detect the aircraft and trigger at optimal range automatically. German jet pilots reported that American anti-aircraft fire had become effective even against their advanced aircraft. The industrial scale of VT-fuse production demonstrated American manufacturing prowess in ways that impressed even German engineers. By war's end, production reached 2.1 million fuses monthly from multiple contractor facilities. Each fuse required 127 precision components assembled to tolerances measured in thousandths of an inch. Quality control standards demanded that fewer than 1 in 1,000 fuses fail to detonate properly. American industry achieved these specifications while simultaneously producing aircraft, vehicles, ships, and conventional ammunition in quantities that dwarfed Axis production. Despite security protocols, German intelligence eventually captured relatively intact examples. In January 1945, a VT-fused shell that failed to detonate was recovered from frozen ground near Bastogne. German electronics specialists examined the device at the Telefunken laboratories in Berlin. Their analysis confirmed what intelligence reports had suggested, but seemed too fantastic to believe. The Americans had miniaturized radar to fit inside an artillery shell. Dr. Erich Haberland, Telefunken's chief engineer, prepared a technical assessment for the Reich Ministry of Armaments. The American proximity fuse represents an order of magnitude advancement in electronics miniaturization and manufacturing. We cannot replicate this technology with current German industrial capacity. Even if we received complete blueprints today, we lack the production facilities, materials, and skilled workers to manufacture these fuses in meaningful quantities. The precision required exceeds our machine tool capabilities. The psychological impact of technological inferiority extended beyond frontline troops to German scientific and industrial leadership. Nazi ideology had promoted German technical superiority as a pillar of racial doctrine. Yet here was incontrovertible evidence that American engineers had outperformed German scientists in a field where Germany had pioneered development. Albert Speer, Reich Minister of Armaments, mentioned the proximity fuse specifically in his memoirs. The American VT fuse represented the kind of technological achievement that Nazi ideology insisted was impossible for a mongrel democracy. Yet they developed it, perfected it, produced it by the millions, and deployed it before we even understood what was happening. This weapon alone killed more German soldiers than any other American technological innovation. Post-war interrogations revealed the profound impact proximity-fused artillery had on military effectiveness. Colonel General Alfred Jodl, Chief of Operations for the Wehrmacht High Command, testified at Nuremberg, American artillery superiority in 1945 was not primarily numerical, it was technological. Their proximity fuses transformed artillery from an area weapon requiring multiple corrections into a precision weapon that achieved effect on first salvo. Our casualties from American artillery in 1945 exceeded all previous years combined. Field Marshal Wilhelm Keitel was more direct. We could not counter American artillery in 1945. Our soldiers called it the American Wunderwaffe. Every shell exploded at perfect height. Our foxholes offered no protection. When American artillery fired proximity shells, German forces ceased to be combat effective within minutes. The statistical evidence of VT fuse effectiveness is overwhelming. Traditional high-explosive shells with impact fuses achieved approximately 2.5 casualties per shell when firing for effect. VT-fused shells achieved 12 to 16 casualties per shell in the same circumstances, an effectiveness increase of 500%. This multiplier effect meant that a single American artillery battalion using VT fuses had firepower equivalent to 5 battalions using conventional ammunition. Against aircraft, the statistics were even more dramatic. Pre-VT anti-aircraft fire achieved approximately 1 aircraft destroyed per 20,000 rounds fired, a hit rate of 0.005%. VT-fused anti-aircraft fire achieved hit rates exceeding 50% under optimal conditions and 20% in actual combat. This 1,000-fold increase in effectiveness transformed anti-aircraft artillery from a weapon of dubious utility to a decisive defense system. From August 1942 to August 1945, American contractors produced 22 million VT fuses. Each fuse cost between $42 and $52. Total program cost approached $1 billion 1940s dollars. Yet this investment was considered among the war's most cost-effective, as the fuses saved ammunition, reduced gun wear, shortened engagements, and most importantly, saved lives by reducing exposure time to enemy fire. Individual German soldiers' accounts from the period reflect the psychological impact. Corporal Wilhelm Hoffmann of the 26th Volksgrenadier Division wrote in his diary on January 12, 1945, "The American artillery has become something else. The shells explode above us now, every single one. Our helmets and foxholes mean nothing. Men are dying who would have survived a month ago. The Americans have removed the soldier's advantage and made killing scientific." Private Hans Kramer, captured near Remagen in March 1945, told interrogators, "We called the proximity shells Kopfenjäger, headhunters, because they always exploded at head height. You could be in the deepest foxhole and still die." The fragments came from directly above. After 2 days under that fire, men wouldn't leave their positions even when ordered. Field Marshal Walter Model, commanding German forces in the final defensive battles, noted in January 1945, "American artillery has become impossible to counter. Their proximity fuses create killing zones of scientific precision. Traditional military responses, dispersion, concealment, movement, all fail against this technology. We are fighting 20th century warfare with 19th century responses. The gap is unbridgeable." The lasting legacy of the VT fuse extends far beyond World War II. The technology demonstrated that electronics miniaturization and mass production could transform conventional weapons into smart weapons. Modern guided missiles, smart bombs, and autonomous weapons all descend from this innovation. The principle remains identical: allow the weapon to make decisions about optimal employment, removing human reaction time limitations. For German forces in 1944 to 45, the proximity fuse represented a convergence of everything they had been taught to dismiss about American capabilities. The supposedly inferior mongrel democracy had out-engineered superior Aryan scientists. The nation of mass-produced consumer goods had created precision electronics that German craftsmanship couldn't replicate. Every VT-fused shell that exploded above German positions destroyed not just soldiers, but Nazi ideology's foundational myths. The proximity fuse's greatest impact wasn't the soldiers it killed directly, but the operations it prevented. German counterattacks that should have succeeded failed under VT-fused fire. Defensive positions that should have held for weeks collapsed in days. Movement that should have been possible became suicidal. The weapon didn't just kill, it paralyzed. In the end, Oberst Wilhelm Mohnke reflected in a 1978 interview, "The proximity fuse showed us we had already lost the war before we realized it, not because we lacked courage or skill, but because the Americans had made warfare scientific. They turned artillery from an art into a science. Every shell burst at the perfect height. We couldn't hide, couldn't maneuver, couldn't survive. That was the moment we understood that will and sacrifice couldn't overcome mathematics and physics. The Americans had industrialized killing. We fought on for months, but we were already dead. The proximity fuse had killed us. We just hadn't stopped moving yet." Image descriptions needed. 1. German soldiers in foxholes during artillery barrage. Ardennes winter 1944 to 45, showing defensive positions. 2. Close-up technical diagram or photograph of VT proximity fuse internal components showing vacuum tubes. 3. USS Cleveland conducting anti-aircraft gunnery tests, August 1942, firing at drone targets. 4. American factory assembly line producing proximity fuses showing mass production 1944-5. B. 17. Flying Fortress under attack with VT fused anti-aircraft bursts around German fighters. 6. Battle of the Bulge. American artillery positions firing, winter conditions with snow. 7. German panzer forces under artillery fire with airburst explosions visible above positions. 8. captured German officers examining proximity fuse components at Intelligence Facility 9. Dramatic shot of multiple artillery airbursts creating umbrella pattern over battlefield, thumbnail option 10. Close-up of VT fuse being loaded into artillery shell, showing size comparison, thumbnail option 11. Night photograph of VT fused illumination rounds lighting up battlefield, thumbnail option 12. German soldiers taking cover as proximity fused shells detonate overhead, Ardennes, thumbnail option 13. Technical cutaway illustration of proximity fuse showing radar components, thumbnail option 14. American 105mm howitzer crew loading VT fused ammunition, 1945, thumbnail option 15. Comparison shot showing traditional ground burst versus proximity airburst effect, thumbnail option. The VT fuse program employed approximately 26,000 workers directly in fuse production facilities, with hundreds of thousands more in component manufacturing. Contractors included major corporations like General Electric, Sylvania and Westinghouse, as well as smaller firms like Crosley Corporation that had produced radios before the war. This industrial mobilization exemplified American capacity to transform civilian manufacturing into war production on unprecedented scale. The cost efficiency of proximity fuses revolutionized military economics. A VT-fused anti-aircraft shell cost approximately $52 in 1944. Destroying an aircraft using conventional shells required an average of 20,000 rounds at a cost exceeding $25,000. A VT-fused battery typically destroyed aircraft with fewer than 100 rounds, costing less than $6,000. The proximity fuse transformed anti-aircraft fire from economically dubious to cost-effective, enabling sustained air defense that would otherwise have bankrupted even American resources. For ground artillery, the economic case was equally compelling. Achieving suppression of a target previously required multiple fire missions, with ranging shots, corrections, and sustained fire for effect, consuming hundreds of shells and exposing gun crews to counter-battery fire. VT-fused artillery achieved suppression with a single volley, saving ammunition, gun barrel wear, crew exposure time, and most critically, tactical time. German forces that required minutes to take cover after ranging shots began had no warning with VT fire. The first volley was the effective volley, collapsing the observe-adjust fire cycle into a single devastating moment. The human cost of the VT fuse from the German perspective is difficult to calculate precisely, but military historians estimate the weapon system was responsible for 25 to 30% of all German casualties from artillery fire in 1945. Given that artillery caused approximately 60% of total combat casualties, proximity fuses may have been responsible for 15 to 18% of all German combat deaths in the war's final months. For a single weapon system deployed for less than 1 year of ground combat, this impact was unprecedented in military history. The Battle of the Bulge marked the turning point where German forces first confronted VT-fused artillery in large numbers. Post-battle analysis by American operational research teams showed that German units facing proximity-fused fire suffered triple the casualties of units facing conventional artillery when both received equivalent tonnage of shells. More significantly, units hit by VT fire required 3 times longer to recover combat effectiveness even after replacement personnel arrived, indicating that the psychological damage exceeded the physical destruction. German attempts to develop countermeasures failed completely. Proposals to deploy smokescreens were ineffective because VT fuses detected the ground through smoke. Plans to jam the fuse's radio frequency were abandoned when technical analysis revealed the fuses operated on frequencies that changed with each shell's unique spin rate, making targeted jamming impossible. Suggestions to develop armored overhead cover for all positions were dismissed as requiring resources Germany simply didn't possess in 1945. The proximity fuse represented not just technological superiority, but a fundamental difference in how America and Germany approached warfare. Germany sought the perfect tank, the fastest jet, the most powerful gun. America sought the most effective system, the most reliable weapon, the most producible technology. The VT fuse embodied this philosophy perfectly, a weapon that worked the first time, worked every time, and worked in such quantities that effectiveness through volume overwhelmed tactical brilliance through scarcity.